Today we're going to move on to probability, and in the simplest context, the probability of any event is basically the chance that something's going to happen or how likely this event will happen. And the calculation is the same calculation you probably used in 7th grade or whenever you studied a little bit of probability, the number of favorable outcomes over the total number of outcomes. And that's at its simplest state. It's a much more complex topic, but in the simplest state, it's a simple fraction. So here is your 7th grade problem. If there's 5 pencils and 4 pens in a bag, what's the probability of reaching in and drawing out a pen? And basically there's 4 likely chances of that happening. So we pop a 4 on top of our ratio, and there's 9 total things that could happen. So 4/9 is going to be your probability, and that's as easy as it'll ever get. But we're going to move into some high school oriented probability and take a look at this problem. So we've got 6 men and 3 women on a committee, and we're going to make a subcommittee of 2, and we want to know the probability that that subcommittee is made up of 2 women. Now, within this problem is a combination problem because they're asking us to group a specific set of people from a total amount of people. So we've already kind of done this problem in the combination fashion. Now we're going to apply it to probability. So if we want on top the number of ways that we can be successful at this, then on top we have to choose just 2 women. We've got to make sure the men aren't involved in the picture. So in order to get that problem done, we have to take and say, all right, well, if I'm looking at just the pool of women, I've got 3 women and I'm picking 2 of them. So 3C2. And then the bottom, I need the total number of ways I can pick 2 people. So I've got 9 total people and I'm picking 2 or grouping 2 of them, and it doesn't matter the order in which I group them. So this would be the ratio I'd use to write that probability. And then you could pop that into a calculator and get that done. And that's going to get us 1/12. Let's move on to the next example. Very similar example. You've got 3 animals that you're going to choose from a total of 13, and you want to ensure that you have 1 of each animal chosen. So again, we're going to ensure we take 1 from the lions, 1 from the tigers, and 1 from the bears. So if I'm looking at just the lions, this is a combination problem, 4C1, and then 6C1 for the tigers, and 3C1 for the bears. I've got a total of 13 animals, of which I'm choosing 3. In order doesn't matter. And that's going to get us whatever fraction we need. I'm going to stop calculating these out because you can do those from there. So now we talk odds, which is a variation of probability. Odds is calculated by the number of favorable outcomes, just like probability, but in the denominator we take and put that over the unfavorable outcomes, whereas probability talks about all the total outcomes. So let's do an odds problem with a little different technique. We're going to look at 2 dice being rolled. We call them 2 fair dice because they aren't weighted or anything like that. We want to know the odds of rolling a 7. So what I've done, and this is the way I like doing the problems, is you assume the dice are distinguishable. So we give them their own values. Right? Here's dice 1, if you will, on top, and dice 2 is on the side. And they have 6 different rolls each. So totally we have 36 possibilities for this to happen, and I've indicated that in this chart. I usually do most of my dice problem in a chart just because it's easier to see. So what I want is I want to roll a 7. So when I roll a 7, I get a 6 and a 1, a 5 and a 2, a 4 and a 3. This is a different 4 and 3, different 5 and 2, different 6 and 1. Can I look around and see, are these the only ways to get 7? Sure is. So what I need to do now is I need to take the number of favorable outcomes, and my favorables in this case are all the x's. So what I have is I have a total of 6, it looks like. And then I need to put that over the unfavorable outcomes. Well, I said I had 36 possibilities. And that came from multiplying 6 choices on one dice from 6 choices on another dice. So if I take 36 and subtract 6 off that, I have the number of unfavorable outcomes, which is 30. I can reduce those to a fifth, and those are my odds for rolling a 7. So now, again, given 2 fair dice, what are the odds of rolling at least 1 2? So this is having a 2 on a dice. All right. Well, if I go over to here, if I have a 2 on dice 1, again, call this a 2 on dice 2, I could have a 2 on dice 1 in all these possibilities. So that's one way of rolling at least 1 dice. Now, you'll notice here I have a 2 and a 2. It says at least 1, so I could have two dice with 2 on them. So if I roll dice 2 and I have 2s on those dice, then I have all those possible rolls. So totally, I have 11 possibilities of that happening. And if I have 36 total rolls, I have 25 possibilities that it won't happen. So here are the odds of that. Now we're going to mix odds and probabilities up, I think. A lot of probabilities based around card probabilities and game probabilities for poker and such. So for those of you who don't have a lot of experience with cards, these are the denominations of cards on the top, ace to king, and then we have 4 suits: clubs, diamonds, spades, and hearts. So study that a little bit, and you can always come back to it or write it down or do what you need to do. But you need to know what's in a set of cards. And let's move to our problems. So we're talking about a standard deck of playing cards, which is 52 cards. And we want to know what the odds are of drawing 5 cards out such there are 4 cards from one suit and obviously 1 card from another suit. So this is, again, a grouping style problem. All right. And what we need to do is decide exactly what type of cards we're picking, what kind of things that we're choosing, or what are our different groups. Well, in this case, we have groups that relate to suits. We have groups that relate to cards in one suit. And groups that relate to cards in the second suit. So we've got 3 combinations we're going to have to use. What I do know, if I'm talking about odds, is I'm going to have to take the total number of ways to draw 5 cards and subtract from that the number of ways to get the items that we want. That'll give us the number of things that we can't get, because that would be too hard to calculate. So if I want to figure out, all right, well, what are the different combinations of suits I could have? I have 4 different suits. And from those, I'm picking 2. So that deals with the type of suits I could have and the different combinations of those I could get. Next, we're going to deal with the suits, or the cards in the first suit. So I want 4 cards from one suit. I have 13 total cards in whatever suit comes up, and I'm going to choose 4 of them. No order important. And then for that second suit, again, I'm going to have 13 cards, but I'm only choosing 1. So these are the number of ways that this is likely to happen. Now we have to put this over the ways this can't happen, which would be the total number of ways, or 52 choose 5, that's the total. subtracted by the number of ways it can happen, which is what's on my numerator. So that's 4C2, 13C4, and 13C1. And then you could grind that out using a calculator. All right. So I guess that's all I've got for you today. Some probability style problems and some odds problems. Answer these 4 questions, and we'll take a look at probably a couple of them tomorrow, since I would imagine that this is going to give some of you some problems. Okay?